What's going on, Team Geometry? Achievement first. Royals represent. Anyway, enough of that. Alright, I'm going to talk to you about the Law of Cosines, so let's get into it. First thing we need for the Law of Cosines is a triangle. So I start with a generic triangle, ABC. You'll notice I put the sides across from the letters as lowercase versions of them. In every triangle I can drop an altitude, so I'm going to go ahead and do that from vertex C. As you'll recall, with altitudes, they form right angles. When I do that, you'll notice what happens is that C, which is the side AB, which is of length C, the whole side AB gets divided into two segments. Here's one of them, here's the other one. So I'm going to go ahead and name those two segments. I'll call them E and F, and then I'll need the altitude, I'll call that G. Sorry, that G is a little ugly. Let me redo it. Like that. Okay, so if you look in this triangle right here, this is a right triangle. Picture what Pythag would look like. Apply the Pythagorean theorem. What equation would you get? Hopefully you're thinking E squared plus G squared equals B squared. All right. In the same triangle, I can also apply SOHCAHTOA, right triangles. So if you notice, I have a right triangle like I said. Picture A as your reference angle. What is the cosine of A? Hopefully you're thinking the cosine of A is E over B, adjacent over hypotenuse. It's the adjacent side divided by the hypotenuse. Just keep note, opposite side would have been G, but in cosine we don't use the opposite side. So if I want to solve this equation for E, and you'll find out why I want to in a second, I need to get rid of this B on the bottom. How do I do that? Hopefully you're thinking multiply by B. Everything will cancel out. If I multiply by B, what happens? Well, I am left with B cosine of A equals E. Alright, so I found E in terms of B and the cosine of A. While we're talking about E, I'm going to focus. I'll just finish talking about E. Or I'll talk about the segment AB. This one right here. So while I'm talking, since I've mentioned E, I'll just continue my focus here. So if you look at AB, you know that E plus F together, if I take E and I add it to F, together they would make C. So let me write that. E plus F should equal C. Well, you'll find out why I'm doing this later, but let's say I want to find F by itself. I already know E is B cosine of A. That came out right here. So where I see E, I'll sub that in a second. First, let me just get rid of this. So E, I'm going to subtract from both sides. So then I'll get F by itself. F equals C minus E. And then substituting in, as we just said, anytime you see E, you really know that E is the same as B cosine A. So instead of saying E, I'm going to write B cosine A here, like that. Alright, so now I have found E in terms of cosine of A and F in terms of cosine of A. Those came, in case you're like, what are you talking about? Where's my laser pointer? Laser pointer, come back. Alright, I'll use my laser arrow. It's sort of the same thing. Alright, so here I have E in terms of B cosine A, and our E in terms of cosine A is my main focus. And then here I have F also in terms of the cosine of A. It's the law of cosines, so the fact that I have cosines here is a good thing. So now let's go back to sort of the basic stuff. We first talked about the Pythagorean theorem here. E squared plus G squared equals B squared. Now I'd like you to think about what would the Pythagorean theorem look like in this right triangle here, this smaller right triangle. Alright, so I've stalled for you for long enough. Alright, so hopefully what you were thinking was something like this. Pow. Alright, so that's what I'm hoping you were thinking. So again, we've already talked about F squared and G squared. Or I guess that's not true, sorry. We've talked about, where's my laser? We talked about G squared before. Like we saw G squared here in our first Pythagorean theorem. Quick note, I don't think I mentioned it yet, so let me just back up. This triangle that we're talking about originally ABC. Just a generic triangle is what I said before. I mean, just it's an oblique triangle. It doesn't have to be a right triangle. But when I drop the altitude, I create two right triangles. There's one, and there's one. Okay, so we've seen g squared before. I'm going to take g squared in this equation and isolate it. So let me get in close. So g squared, if I were to move the e squared, that's keeping it company, would be the same as b squared minus e squared. All right, so that's subtracting e squared from both sides. So over here where I see g squared, all right, there's my same g squared. I now know, well, g squared is b squared minus e squared, so I'll substitute that in here. So there it is, plus f squared. Let me redo that. I didn't really redo it, I just traced over it a bunch of times. So b squared minus e squared plus f squared equals a squared. I'm going to rewrite the left side of this equation. I'm just going to reorganize it. It may not be clear to you why. The reason is, and for those of you who have had Algebra 2 before, this means something to you. You may have heard of the term difference of squares. Difference meaning subtraction, squares because both of these things are squared. Let me just write that here. By creating a difference of squares, I have something that I can factor. So the way I factor my difference of squares is like so. I have b squared. Writing 2's on this thing is very difficult. And so is f's, I guess. This factors to f minus e times f plus e equals a squared. Unfortunately, I won't win any handwriting awards for this. So what I want you to notice is here I have f plus e. And if you think about it, if you look back at our picture, what would f plus e equal? Like if you added up f and e together. Hopefully what you're thinking is c. So if I look at f plus e, what I'm saying is that altogether, f plus e would just add to c. So I'll rewrite this equation, just making that step clear. So b squared plus, I just haven't changed anything, plus f minus e times c equals a squared. All right. Well, we've talked about e before, but I'm going to, and f actually, but I'm going to pause here and I'm just going to do the distributive property on this expression. I have c times f minus e. So think about if I distribute the c into this, what will I get? Hopefully what your thoughts are is something that looks like this. B squared plus f times c, or plus fc, minus ec equals a squared. Okay, now the question becomes, have we seen e before? Yes, we have. If you're like, where? Just I'll zoom out here. You'll notice we said that e was b times cosine a. So where I see an e, I'm going to write b times cosine a. Also, where I see f, well, I said f was c minus b cosine a. So where I see f, I'm going to write c minus b cosine a. I'll keep the colors the same, so I'll do this in orange, I'll do this in blue, and let's see what this turns out to look like. So the end is drawing near. I appreciate your staying focused for so long. So as I do this, again, just to notice, I'm going to sub out instead of f, what I'm going to write instead of f is c minus b cosine a. I'm going to try to write it. Okay, let me zoom in. Let me not act like my handwriting is that good. I have to be up close and personal. C minus b cosine a. And for e, we said we were going to substitute in what now? There it is. Pow. And let's see. I think I may have forgotten my right side of my equation. A squared. A squared. Okay, so this looks really messy, but it actually turns out to be pretty nice. If I distribute all this here, I have b squared plus Just notice, again, I have c distributed into this. That will give me c squared minus bc times the cosine of a. Minus, distribute one more time. And when I say distribute, I'm saying distribute this c into what you see here. bc cosine a. That looks horrendous. Let me clean that up. bc times cosine a. And this all equals a squared. So now, this may not look like much, but this is actually a pretty big thought. You'll notice something, hopefully, about these two expressions. They're actually the same. All right. So now the grand finale, final conclusion. What I'm saying is this: a squared, what I have on my right side, is equal to b squared plus c squared minus 2. What? Sorry, let me try that again here. 2 bc cosine of a. So right here, boom. That's sort of annoying. Alright, right here I have the law of cosines for you. B squared plus c squared minus 2bc cosine of a equals a squared. I'll just point out one thing. It looks a little bit like something you've seen before. A squared equals b squared plus c squared. It looks like a weird variant of the Pythagorean theorem with this thing thrown in here. And we'll talk about what that is in just a bit. Thanks for watching.